So there is something really cool that happens when we start dividing the numbers in Fibonacci sequence. So we just take two numbers at a time and take the bigger number and divide the smaller number. I mean, you could do it the other way around. You could get a different ratio that's just reciprocal. But what we're going to do is finish dividing out these numbers. We've done a few of them already. So we have 1 divided by 1, those are the first two numbers, we just get 1, and then 2 divided by 1, which is 2, 3 divided by 2, which is 1.5, 5 divided by 3, which was 1.66666, repeating, but we just rounded it to 1.667. Now let's do 8 divided by 5. Who has that one? Isn't it just still 1, 1, 6? 1, 6, right? Just 1, 6. Okay. And then 13 divided by 8. Okay, and then 21 over 13. 1.615. Okay, 34 over 21. And then 55 divided by 34. Okay, what was the number after the 7?
The entire history there.
So 55, okay, so 1.6176.
Yeah.
So 1.6176. So when we want to round up to 3 decimal places, this number is bigger than 5. So that means we round that number up, which is why our number goes up to 0.61. So isn't it kind of weird that, well, it started bouncing back and forth between 1 and 2. Then it just started honing in on this 1.6 and gets closer and closer to its value, right? So this is what we call the golden ratio. Like the bigger numbers we use in Fibonacci sequence to divide, the closer we get to this golden ratio, which is approximately 1.618. So here's just a little picture. Might be confusing, but this is just saying if you add two numbers together, and those two numbers have this 1.618 ratio, then the length you get when you add them together is going to have that same ratio to the larger length of the two. And that process just repeats over and over and over, just like Fibonacci sequence. We take two numbers, we add them together to get the next number. Well, those numbers are just going to keep getting closer and closer to this ratio, called the golden ratio. Now this is a Greek letter. So for the golden ratio, we sometimes use this Greek letter phi. Greek letter phi for the golden ratio, just like when we're doing like circle stuff with diameters and radiuses, we often use the Greek letter pi to represent a different number, 3.14. And there's other important numbers like that out there in math as well. This is the one we're talking about right now. So what we're doing next is we're going to watch a little video for Donald Duck and Magic Land. And the video is going to show us all sorts of places where we see that golden ratio. It's not all about the golden ratio. There's other math in it too, but that's the main exciting focus today. So he talks about, well, yeah, the narrator in this video talks about the pentagram, which is a star shape, and how the different lengths of pieces in a pentagram actually have that same golden ratio. So it's kind of cool. So golden ratio sometimes is also called a golden rectangle or a golden section. And the video is going to talk about different places where you can see that. We will do this part together after we watch the video, which is about a half hour. While you're watching the video, you're going to be answering the questions in Canvas. So I need y'all to get your Chromebook out and ready, and behind that is the announcement today, so we can do that while we're watching. before you watch the rest of this video, please watch Donald Duck in Mathmagicland and do the quiz assignment in Canvas. Alright, now we're going to fill in this page 7 of our notes. So from our movie we saw how the pentagram has portions, like the little lengths in a pentagram and a star are actually proportional by the golden ratio. So let's just write down some of the things that the video mentioned, places where we can find the golden ratios in our lives. Just make a list with me. Where? Sure. Yeah, a poster might be a golden rectangle size, right? Not all posters, but it could be. What specific things that the video mentioned? Oh, so like flowers. So nature, like flowers, seashells. Okay, what other things did the video mention as places where we would find the golden ratio? Yeah, art, like the one we said, right? Okay, what else? This is a different ratio. If statues, I just included that with art sculpture statues. Very good. So architecture, like in buildings and things. So for example, you've got the Greek Parthenon, right? That building that we talked about at first, that had all the little golden rectangles in it, Parthenon in Greece. What else? Oh, the human body. Lots of golden ratio measurements comparing. If you compare, in fact, we're going to do it in sentence today, comparing ratios of measurements in the body to see which ones are the most close to golden ratio. Anything else you can think of that was mentioned specifically on golden ratio? One. We might have covered it already. It gave us plenty of room to write stuff, but I think that's good. You can go back and watch it again if you want to catch other things. Okay, the next page of our notes, there's really nothing to write on. It just is showing you some examples of places where we can find the golden ratio. So you've got like the length of someone's hand to the length of their arm to their elbow happens to be approximately the golden ratio. You've got like spirals in things that grow naturally, and the ratios of the spirals you make rectangles like related to those spirals are golden rectangles with the golden ratio. Lots of logos are designed with the proportions of the golden ratio. Storms can form in spirals that have those same proportions. We've got art, we've got portions of the face. We've got some architecture, like here's a pyramid showing ratios similar to the golden ratio for how the pyramids were built. The Eiffel Tower has golden ratios in it. Here's a picture of the Parthenon in Greece. We've got golden ratios. So you don't really need to do anything with this page. It's just a bunch of examples if you wanted to put anything on it. Okay, so we're not going to worry about the arithmetic and geometric sequences quite yet. Here, I forgot I'm still running a video for people at home. Let me stop this.